The rules for significant figures are on page 23, but I'm going to give you my version. That's how it's going to be all year, sorry. And my version is this. Any non-zero digits are significant figures. Okay, so number one, all non-zero, I can spell, digits are significant. And I'm going to call them sig-figs. Okay? Number two, the problem comes in with zeros. So the second rule I'm going to tell you is zeros are significant if they are to the right of the decimal at the end of the number. It's got to be both. To the right of the decimal at the end of the number. And I want you to think about this for a minute. If I were to write that out, do those numbers have any numeric value at all? No, they don't. So they are strictly placeholders telling you that this instrument was precise to that place, to the 10th place, and therefore we estimate it to the 100th place. There's no numerical value there, but there are significant figure value there. So to the right of the decimal at the end of the number. And the third rule is also on zeros. Zeros are significant if they are between two significant figures. Two significant figures. Okay? And so let's look at that and let's see how that works out. So turn over to page 24, please. On your own, on page 24. All right. And I define a significant figure differently than the book. I tell you the significant figure is estimating one past the precision of your instrument. Okay. On your own, 112. It says how many significant figures are in the following measurements. The first one is 3.0220 centimeters. Now look, you know that's significant. You know those are significant. This zero is between two significant figures. This zero is to the right of the decimal at the end of the number. Therefore, this actually has 1, 2, 3, 4, 5 significant figures. The next one, so you have to work your rules. And there's a lot of cases in chemistry where you have to work your rules. Here, this is a significant figure. It's non-zero. This is to the right of the decimal at the end of the number. But are these significant? They're not between any significant figures. They're not to the right of the decimal at the end of the number. They're to the right, but they're not at the end of the number. Therefore, there's only two significant figures here. Let's look at the next one. 0. Oop, I'm so sorry. I got that wrong. Here we go. 1.00450 liters. Okay. We know these are significant figures. We know these are because they're between significant figures. This guy, he's to the right of the decimal at the end of the number. So that's a significant figure. So there's 6 of them there. 6, 1. I got to see if it's a point or a comma. Point. 0.054 kilograms. Okay. These are significant because they're non-zeros, and this one is between significant figures, so there's 5 there. That was pretty easy. And then this last one, 300,000, that's the only significant figure because these guys are not between significant figures, and they are not to the right of the decimal at the end of the number. I'm going to tell you, oh well, I'll tell you the trick later. There's a trick that they're doing in college now. Oh, I'll just go ahead and tell you. If you wanted to write 100, that's actually 101 significant figure. But let's say you had to write 103 significant figures. The way that we're learning here, you would have to go like this to write 103 significant figures. But my daughter took chemistry in college recently, and they told her that if she put a point there, a decimal, it's telling her that you count all 3 of these. This is telling you that anything in between is significant. I just want you to know the colleges are doing it that way, which I think is cool. Because then you don't have to write it this way. You can actually write it that way, and it's still 103 significant figures. So I just want you to be aware that's what we're seeing at the colleges now, and I think it's pretty cool. Then on page 25 and 26, you're learning about scientific notation. And scientific notation, if I were to do it with letters, A, B, C, D, E, okay, the decimal is really here, isn't it? So scientific notation is where you get one non-zero digit to the left of the decimal, and that you only use the number of significant figures that you actually have. So here, let's say these are all non-zero digits. So it's going to go 1, 2, 3, 4. So you're going to write this as A, point B, C, D, E, times 10 to the 4th. Okay, because I moved it 4 times this way. Let's say originally it was this, A, B, C, D, E. Then we're going to move it 1 this way, so it's going to be A, point B, C, D, E, times 10 to the negative first, because I moved it, it was fractional, and I moved it the other way. Okay, so that's how you do scientific notation. And so let's look on page 28. On page 28, it says, convert the following numbers from decimals to scientific notation. And so the first one there we have 2, 6, 0, 8, 9, comma. Okay, 0, 0, 0. So our decimals back here, we're going to go 1, 2, 3, 4, 5, 6, 7. So it's 2.6089 times 10 to the 1, 2, 3, 4, 5, 6, 7. Seventh, and the significant figures are the non-zero digits plus the 0 that's between the 2 significant figures. Okay? Okay. All right, let's do B. We have, wow, a really long number. Million, billion, 12 billion. 3. 12 billion, 3. And we're going to do this in scientific notation. So we're going to take it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 1.2. Now we have to have all the ones that are significant figures. And we know that these are significant figures because they're non-zero numbers. But look at these. All of these are significant because they are between 2 significant figures. Doesn't matter how far. So we're going to have to write them all. 3, 1, 2, 3, 1, 2. Times 10 to the 1, 2, 3, 4, 5, 6, 7, 9, 10. So that's how we write that in scientific notation. Let's see. The next one is point. And then we have 4 zeros. 2, 3, 4, and then 9, 8, 7, 0. And so we are going to move our decimal place so that we have 1 non-zero digit to the left of it. So it's 9.870. This O is to the right of the decimal at the end of the number, so it counts. Times 10 to the 1, 2, 3, 4, 5, negative fifth, negative because it actually was fractional in the first place, and we moved it that way. You know, this moving it to the right, I get a negative, to the left, I get a positive. That always messed me up because then on a test it was too easy to go which one was right and which one was left. But for me, if I look at it and I know it was fractional, it gets a negative exponent, and if it was a large number, it gets a positive exponent. That was more concrete for me, so I'm just telling you what helped me. Okay, and then the last one there is 0.980. We just move it 1 place, so it's 9.80. This 0 is to the right of the decimal at the end of the number, therefore it is significant. So it would stay in there, and we have times 1, because it only moved 1 place. And then on 114, right below it, we're supposed to convert back the other way, which you'll have to do both on your first test. And so we have 3.456 times 10 to the 14th. The 3, 4, 5, 6, and the point is here. So we're going to go 14 places back. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then every 3, I go back and give commas. And there you go. The next one, B, I have 1.2341 times 10 to the 3rd. So I'm going to move it 3 places this way. 1, 2, 3, 4.1. The next one, 3.45 times 10 to the negative 5th. This time we're going this way. 1, 2, 3, 4, 5. So it'd be 0.1, 2, 3, 4, 3, 4, 5. Okay, and that way, I don't know about if you've seen this, but this means I put zeros in each of these places and then put my decimal there. And that's my new number. This little hump thing works for me. It's very concrete, and I like concrete. It helps me. So if you don't want to do it that way, that's fine. But for those of you that might find that helpful, please feel free. And then this last one here is 3.10 times 10 to the negative 1. So it's just going to move one place that way. So 0.310, and, well, we know that those are all significant, so we have to keep those there. Okay. And then we've really already gone over, and I'll just mention it again to you, we've really already gone over that with significant figures, when you're adding or subtracting significant figures, then you want to go to the least precise, and whatever the least precise of what you started was, is how you're going to end it. The example given in the text is, we measure a knife to be 25.46 centimeters long. And then it says that if you measure the handle with a less precise ruler, we got 7.8 centimeters for the handle. And so if we want to determine the length of the knife's blade, we would subtract these two. And if you do that, the answer is 17.66 centimeters. But when you add or subtract, you have to go with the least precise of your instruments, and that's what your answer has to be in. So let's look at this. This is to the tens place, the hundredths place. This is to the tens place. So this has to be to the tens place. The answer has to be to the tens place, which means we will rewrite this as, it's got to be to here, but that 6 rolls that the other 6 up. So it's going to be 17.7 centimeters would be the proper number of significant figures. When we multiply and divide by significant figures, now it's really easy. It's kind of like when you add and subtract with fractions, you got to come up with a common denominator, which is a lot harder than when you multiply or divide fractions. It's the same way with significant figures. When we multiply or divide significant figures, you go ahead and get your answer, and then you just count who of your factors has the least number of significant figures and answer in that. Let me show you what I mean. On the example problem, it has a student with a mass of a jar. It's filled with sand, and they find the mass to be 546.2075 kilograms. When the jar is empty, the mass of the jar is 87.61 kilograms. Okay, so we're subtracting these two. I'm just going to do both these problems. When we subtract them, the answer that you get has significant figures out to the tens, hundreds, thousands, 10,000ths place. But the original equipment, this one only went out to the hundredths place. So our answer can only go to the hundredths place. That's the adding and subtracting thing. That the precision can't be more than the precision of the least precise that you started with. So that's to the hundredths place. So we're going to rewrite this to the hundredths place. And this number is going to roll this one up, which will roll this one up. So we're going to write it as 458.60, and that's how we're going to write that. Now the multiply and divide one, we have a woman runs 3 miles and 12 1,000ths, I'm so sorry, and it takes her 0.430 hours to do that. There we go. What is her average speed? Well, you divide these two, and in your calculator it shows you there. You get a really long number. But multiplying and dividing, you count your significant figures, and your answer has to be in the less number of significant figures of what your factors were. This one has 1, 2, 3, 4 significant figures, the numerator. The denominator has 1, 2, 3 significant figures. So your answer has to be in 3 significant figures. So you would answer 7.00 miles per hour, and that would be your answer in the right number of significant figures. So the significant figures, they're very important because even if a scientist is on the other side of the world, when you read his work, you know what the precision of the instrument that he used is by the number of significant figures, because you know that he's estimated 1 past the precision of his instrument. And so it's very powerful, important information to that extent. And you will be expected to use significant figures throughout the course. I just want you to know that. So, and don't panic right away, guys. we're going to practice it and practice it and practice it together. And I'm not going to take off a lot of points until you've been able to practice it a little while. So don't panic. But do work on it and try to do it. Go over the rules. Remember that anything that's a non-zero digit counts as a significant figure. Zeros between two significant figures are significant figures. And if a zero is to the right of the decimal at the end of the number, it's a significant figure. So remember those rules and have a Jesus-filled week. Finish the chapter. Do the best you can on all the study guide questions, the review and practice problems. And have just a really blessed week. Thanks. Bye-bye.